All right, on our notes today, it says a construction worker accidentally drops a brick from a high scaffold. What's the velocity of the brick after 5 seconds? So this is a drop problem. Because it's dropped, I know that my initial velocity is 0. I know that my acceleration is due to gravity, which is 9.8 meters per second squared. And the first part of the problem gives me the time of 5 seconds. And it wants to know, at 5 seconds, what is the final velocity? So I'm going to use A equals VF minus VI over time. I'm going to plug everything in. To look like that. Once I have that, I need to get rid of my fractions first. So I'll put this over 1. I'm going to cross multiply it. Negative 9.8 times 5 should be negative 49 is equal to VF minus 0. So my answer is negative 49 meters per second. The second part of that equation asks for how far does the brick fall during this time. I have acceleration, I have VI, I have VF, I have time. I could basically use any of my 3 formulas, so I need to look at which one I want to use. Obviously, I don't want to use the same one because I need distance. I'm just going to use my distance formula. Distance equals initial velocity times time plus 1/2 times A times time squared. Okay. I think some of y'all, when you're putting them in the calculator, are putting this in a little bit wacky, and the calculator's not liking what you're doing. So my initial is 0. My time is 5 seconds. Plus 1/2 can also be written as 0.5. Negative 9.8 5 squared. Okay, I'm going to simplify this a little bit more. 0 times 5 is 0. So negative 4.9 times 25 is equal to my distance. So my distance is going to be 122.5 meters. How can you have a negative distance? It's because it's down. Remember, we're looking at the y-axis, which is up and down. So that negative tells me it fell 1,225 meters downward. Any questions? We good? A tennis ball is thrown straight up with an initial speed of 22.5 meters per second. It's caught at the same distance above the ground. VI is 22.5 meters per second. Acceleration, negative 9.8 meters per second squared.
Why did I use the positive?
Time.
Why did I use the positive back then?
Time. Time. If you're looking for time. So it wants to know how high does a ball rise. We gotta find the distance. I'm going to find, because here's my ball. I tried to make those even. I didn't. I added an extra one. I don't know why. I'm going to find out the distance here. At that very top, what is my final velocity? 0. Just for that very instant, my final velocity is equal to 0. I do not have time, so I have to use that formula. So it becomes negative 9.8 equals 0 squared minus 22.5 squared divided by 2d. Put this over 1. Cross multiply. 19.6d equals 22.5 squared, negative 506.3. Okay, now I'm going to divide both sides by negative 19.6. To give me a distance of 25.8 meters. It's third period. Okay, the second part asks, how long does the ball remain in the air? So I'm going to find out how long the ball rises to the top. I'm going to use my same values. Acceleration equals VF minus VI over time. Negative 9.8 equals 0 minus 22.5 over time. Put this over 1 and cross multiply. So my time to get to the top, my time spent traveling up, is 2.29 seconds after I simplified it. I divided both sides by negative 9.8. It didn't ask me how long it spent rising. It asked me for the total time. So remember, time up equals time down. Time up equals time down. So to find my total time, two times 2.29 is going to be 4.59 seconds. Because, yep, this side is 2.29. This side is going to be 2.29. So just multiply it by 2. So it's going to be 4.59 seconds. You just have to flip a coin to determine whether to do your physics or English homework first. The coin is flipped straight up. What is the velocity of the coin at the top of its trajectory? 0. If the coin reaches a high point of 0.25 meters above where you released it, what was its initial speed? Okay, so now we have a distance of 0.25. We have an acceleration of negative 9.8. We have a final velocity at that high point of 0. So all we need is to solve for VI. I don't have time, so I have to use VF squared minus VI squared over 2D. Oh my goodness, I got excited. I'm sorry. Forgot to plug it in before I started cross multiplying and dividing. Woo! Negative 9.8 equals 0 minus VI squared over 2 times 0.25. Now I'm going to cross multiply and divide. 1. So here I'm taking negative 9.8 times 2 times 0.25. Oops. Negative VI squared. So negative 4.9 equals negative VI squared. My negatives can cancel out. I can multiply everything by negative 1. And then I got square root. Plus. So VI should equal 2.2 meters per second. Yours might be a little bit different. If you rounded it someplace, no big deal. If you catch it at the same height that you released it, which never happens for me when I flip a coin, but if you're able to, how much time did it spend in the air? So we want to find the total amount of time. We're going to do that by finding the time it takes to go up again. Using A equals VF minus VI over time. Plug it in again. 9.8 equals 0 minus 2.2 over time. At the end, yes. So negative 9.8t equals negative 2.2. My negatives can cancel out and become positive. I'm going to divide both sides by 9.8 to give me t is equal to 0.22 seconds. Remember, that's really t up. I need total time. Would be 0.22 plus 0.22, which is equal to 0.44 seconds. Any questions? It's not awful, right?